In this video, I will do some examples of multiplication and division with scientific notation. I am Mrs. Serkis, and this is part of Delaware Tech's Math 129, Math for Health Sciences. So the first problem I'm going to do is 1.8 times 10 to the 15th times 3.108 times 10 squared. Now, what we need to recognize is that this is actually multiplying four numbers together. It's in scientific notation, but it's 1.8 times 10 to the 15th times 3.108 times 10 squared. So because this is a series of multiplications by order of operations, we can do them in whatever order we want. And actually, that's not because of order of operations, but because of the associative and commutative properties of multiplication. So what I'm going to do is rearrange it in a much more convenient fashion. So this is the same thing as 1.8 times 3.108 times 10 to the 15th times 10 squared. So what I'm going to do is I'm going to multiply these two coefficients together, 1.8. I'm just going to use my calculator here, or my basic calculator. 1.8 times 3.108, and that gives us 5.5944. And then I'm going to multiply these two powers of 10. And since they are both base 10, we're going to use the product rule for exponents and add those exponents together. So it's 10 to the power of 15 plus 2, so that's going to be 5.5944 times 10 to the 17th power. And that is in proper scientific notation because our coefficient here has exactly one non-zero digit to the left of the decimal point. So this is by definition a number that is at least 1 but less than 10, so that makes it a proper coefficient, and we have our power of 10, so we are finished with that problem. Now let's look at one that's a little bit different. This one is 9 times 10 to the 7th times 2.6 times 10 to the negative 2nd. And we're going to start the same way by rearranging it to make it 9 times 2.6 times 10 to the 7th times 10 to the negative 2nd power. So the same idea that we're smushing together the coefficients and smushing together the powers of 10. So 9 times 2.6, I'm not going to do that one in my head, is 23.4. And 10 to the 7th times 10 to the negative 2, that's 7 plus negative 2 power, so that's 23.4 times 10 to the 5th power. Now one way to go about doing this would be to convert this back into regular notation and then put it in proper scientific notation. But another way of considering it is to say, okay, we're moving the decimal point one place. So we know we are either multiplying or dividing by 10. And if you're like really swift with math, you will recognize that we needed to make this 10 to the 6th power. But if you weren't sure, here's the way we do it. We know we're moving the decimal point one place. How is it going from here to here? Well, it's making this coefficient, it's going from 23.4 to 2.34. So it's getting smaller. Well, we don't want to change the value of this number. We want it to be equivalent to 23.4 times 10 to the 5th. But we want it to be in proper scientific notation, and 23.4 is too big, so we needed to make it smaller. So to balance it out, we're going to make this one larger. So as we're going from one step to the other, since the coefficient had to get smaller, the power of 10 had to get larger. And what you need to be careful of is when you're dealing with negative numbers, larger always means to the right on the number line. So a larger negative number means more towards 0, and it actually has a smaller magnitude, but it's to the right. Okay, so let's consider this one. 4 times 10 to the negative 9th times 8 times 10 squared. So we're going to do the same thing. It's 4 times 8 times 10 to the negative 9th times 10 squared. So 4 times 8 is 32. And negative 9 plus 2 is negative 7. So now this number is too big because the decimal point would be here if it was shown. So 32 is too big of a number, so we're going to make it 3.2. So there's exactly one non-zero digit to the left of the decimal point. So what that means is what's going on here is this is getting smaller. 32 to 3.2 is getting smaller. So here we need to get larger. So what's the next larger number after -7? Well, if we're looking on a number line, here's -7, here's -8, here's -6. -6 is the one that's to the right, so that's going to be 10 to the -6th power. So turning this into a regular decimal number and then putting it back into scientific notation is usually not the easiest way to do things. I'm not going to say you can't do it, but when you're moving the decimal point, if this was, instead of a -7, what if it started as -17? That's moving the decimal point an awful lot of steps and a lot of counting of zeros. Kind of like takes away the whole point of using scientific notation. So let's do one more multiplication problem, and then we'll switch over to division. Okay, so multiplication. 6 times 10 to the -9th, 4.53 times 10 to the -8th. So again, this is very similar to the last one we're doing, so I'm just going to skip the step. 4.53. 6 times 4.53 is 27.18. Times 10 to the -9 plus -8 is -17th power. So again, we can't leave our answer as this. This is not proper scientific notation, so we need to make it 2.718. So because this is getting smaller, this one has to get larger. Therefore, it's 10 to the next biggest number. So -17 is here on the number line. The next biggest number is -16. Okay, so now let's look at division with scientific notation. When we see division, you can think of this kind of like, okay, if this is a fraction, which, division and fractions are two ways of expressing the same concept, we can rewrite this as 8/4 times 10 to the 16th over 10 to the 4th. Because if you started out with this, you can see how this is the same as this, because when you're multiplying fractions, you multiply the tops and you multiply the bottoms. And the reason why we'd want to do it this way is because now we can split up the types of divisions we're doing. So 8 divided by 4 is 2. 10 to the 16th over 10 to the 4th, here we're going to do 10 to the power of 16 minus 4, so our answer is 2 times 10 to the 12th. And we're finished here because there's exactly one non-zero digit to the left of the decimal point. The decimal point would be here if it was shown. And it's another way of thinking of it is that the 2 is at least 1 and is less than 10. Okay, so the next one is a little bit tougher. 3.255 times 10 to the -9th over 3.1 times 10 to the 4th. But again, we're going to start the same way. Then we're going to make it 3.255 over 3.1 times 10 to the -9th over 10 to the 4th. So we're going to start by doing that division. That's not one I can do in my head. 3.255 divided by 3.1 is 1.05 times 10 to the power of -9 minus 4. So this is going to be 1.05 times 10 to the -13th. Notice how we subtracted the bottom here. So 16 minus 4 is positive 12. -9 minus 4 is -13. Don't worry, we'll get a little trickier. Let's do a couple more. Okay, 3.738 times 10 to the 11th over 8.9 times 10 to the -7th. The first thing we're going to do is split it up. 3.738 over 8.9 times 10 to the 11th over 10 to the -7th. So first thing we'll do is 3.738 divided by 8.9, and that gives us 0.42 times 10 to the power of 11 minus -7. And remember, leave, change. So we're going to leave the 11. We're going to change the subtraction to addition, and we're going to change the sign of the second number. So that's going to be 0.42 times 10 to the 18th power. But this is not proper scientific notation because 0.42 is too small. The digit to the left of the decimal point can't be 0. So we're going to switch this over, move the decimal point one place to the right, and make it 4.2. Now, what's going on here is it went from a smaller number to a larger number. So it got larger, which means that the coefficient, the exponent on the 10 has to get smaller. And the next smaller number than 18 is 17. So it's 4.2 times 10 to the 17th power. And again, you could have taken this number and put it, used all the zeros and then figured out what that is, but that's a lot of counting and, takes away the beauty of using scientific notation. So let's do this next one. 1.64 times 10 to the negative 22nd over 2 times 10 to the negative 4th. So we're going to make that 1.64 over 2 times 10 to the negative 22nd over 10 to the negative 4th. So this is going to be 1.64 divided by 2 is 0.82 times 10 to the power of negative 22 minus negative 4. Again, we're going to do leave, change since we're subtracting a negative number. So we leave the first number alone, change subtraction to addition, and change the sign of the second number. That leave, change works for any subtraction. It is especially helpful when you're subtracting a negative. So that's going to be 0.82 times 10 to the negative 22 plus 4 is negative 18th power. And again, this number is too small, so we need to move our decimal point and make it 8.2. So this is getting larger, which means that this number has to get smaller. And those negative numbers can be a little dicey. So here's negative 18. This is negative 17. This is negative 19. The smaller number is the negative 19. So this is going to be times 10 to the negative 19th power. Okay, and the last one is a little bit tricky. And for those of you who are watching this because you're in Math 129, you're probably not going to see any that are very close to this, but you could see this in your science classes. So one thing that makes it tricky is that it's shown sideways, but this means the same thing as 3.875 times 10 to the 14th over 4.5 times 10 to the 3rd. So we're still going to do the same approach, 3.875 over 4.5 times 10 to the 14th over 10 to the 3rd. So here's where things get a little dicey. 3.875 divided by 4.5 doesn't come out pretty. So we're just going to write it without rounding it just yet. 0.861 repeating, and I'm just going to show the dots for now. Okay, times 10 to the 14 minus 3 power. So this is going to be 0.861 repeating times 10 to the 11th. Now, since we are going to need to do rounding, I'm going to do the conversion to proper scientific notation and then the rounding. We'll talk about the rounding in a moment. So we're going to go ahead and start by, okay, so we know we got to make this bigger, so it's going to be 8.6 with a bunch of ones times 10 to the, okay, so this one had to get larger, so this guy has to get smaller, so this is going to be 10 to the power of 10. And now how do we round it? Well, here's where there's a few different ways of approaching this. The proper way to do it is to say, okay, these are science kind of numbers. Let's use significant digits. So significant digits are the number of digits you see when a number is in proper scientific notation. So there's 4 here, there's 2 on the bottom number. Those are the only 2 numbers that are going on. The only operation is division. So by those rules, our answer should have 2 significant digits, which means there should be 2 digits in our answer. So that means that this is the first one, this is the second one, and rounding that off, it gives us 8.6 times 10 to the 10th power. This is a little more advanced than what we would need in Math 129 at Delaware Tech, but I just thought I'd throw it out there. So thank you very much for watching, and I hope you do great in our class.